Hello everyone and welcome to the lecture on Lambda functions. So far we have seen how to define functions and how we can use them. We've seen that we define functions by using the def keyword. In Python we have what is known as anonymous functions or nameless functions, which are defined by using the lambda keyword. And these lambda functions cannot have multiple statements. They can only accept single statement. And we use these lambda functions to create a simple function. Okay, they look like this. Lambda, that's the keyword, and then we have our argument, and then colon, we have expressions. This is the general form for lambda functions, and they are anonymous or nameless because we don't give those lambda functions any name. And this is the format. Mostly these lambda functions are used in conjunction with functions known as map, filter, and reduce. We'll see more of those later on, but you will mostly see lambda functions used in conjunction with these three functions: reduce, filter, and map. Now let's see some examples of how to create and use lambda functions. I'll start by creating a function by using the def statement, the def keyword, and our function, let's name it subtract, or I'll call it difference. So what it will do is it will take two arguments, x and y, and it will return x minus y. X minus y. So this is the normal function definition. Then we can call our function difference and then pass two arguments. Let's say 5 and 3. We get 2 back. Now let's convert this normal function into a lambda function. So lambda takes this form: lambda, argument, colon, and then expression. So that would be the same as we have lambda, then our arguments x and y, colon, and then expression x minus y, right? Our arguments x and y, and our expression x minus y. So this will be the lambda function. Okay, it says the function of main type lambda, and we can save this lambda function in some variable, let's say a, and then we can pass a, and it accepts two arguments, right, x and y. So we can pass 5 and 3 and run it, we get 2. Similarly, we can pass, let's see, 3 and 7, and we should get -4. Okay, so that's how we can create a lambda function. Next, let's define one more function called summation, and our function will take 3 arguments and it will return the sum of those 3 arguments or parameters. So it will return a plus b plus c. So we can call our summation function and pass 3 parameters or arguments, and it will give us the sum of those arguments. So 3 plus 4, 7 plus 5, 12. Now let's convert this into a lambda function. So we have lambda, and then our arguments, which are a, b, and c, colon, and our expression a plus b plus c. That's our lambda function. And we can save this in a variable. Let's call it sum with double m. Now we can call our sum lambda function and then pass 3 variables, 3, 6, and 8, and it will give us the sum of those 3 numbers. What do you think will happen if I only pass, let's say, 2 parameters? I'll get an error. So the lambda function takes 3 arguments and we only gave it 2. So that's the same as what we would get with the normal def function. Great. Next, let's create a lambda function that will add some numbers and divide it by the sum of some other numbers. Okay, let's just say we have a lambda function that takes 3 arguments, a, b, and c, and it will return the sum of a plus b and c divided by, let's see, a plus b minus c. Okay, let's save this in a variable called ratio. So we can call our ratio lambda function our ratio function, and then we can pass 3 parameters. Let's say 3, 8, and 2. Run it. We get 1. So 3 plus 8, 11. That's 13 divided by 3 plus 8 is 11. 11 minus 2 is 9. Oh, let's import the division module, the division function from the future module. So from __ future __ import division, since we are using Python 2, so that we get the actual true division result. Let's run our ratio function again, and then run this. So we get 1.444, and let's make this 8 so that this will give us an error, right? Or a plus b. Let's make this 5. Since the denominator will be 0 in this case, it will give us a 0 division error. 0 division error. Okay. Then if we have some other number here, let's make C a larger number. Let's say 11. Run it. So our result is negative 6.33. Next, let's see how we can use a lambda function with if-else statements. Okay, so we'll define a lambda function, and it will take 2 arguments, x and y, and our lambda function will return the greater of the 2 arguments. Okay, it will return the greater number. So we can say lambda xy return x if x is greater than y, or else return y. So we can save this in a variable called max. Now we can call our max function and then pass two attributes, let's say 2 and 4. So in this case, it will return 4. Right? Takes two arguments and then return x if x is greater than y, or else return y. See, x is 2 in this case, y is 4, and the result we got is what? 4, since it's the higher. We can also say max, and we can say x is equal to 8, and then y is equal to 12. Run it. We get 12 back since it's the greater of the two numbers. We can also say max, return the max of, let's say, 14 times 16. That will be one number, and then the second argument will be, let's say, 13 times 17. Run it. So 224 is the higher of these two numbers, which is 14 times 16. We can also use lambda functions with some of the functions in the math module. We can import math module, and let me show you how we can call the square root of some number by using lambda function. So we can say lambda x, then simply math that square root of x. This is just an example. Okay, and we can save this in a variable called square root, sqrt. So lambda x, so x is our parameter, take x and then return the square root of x. Then we can simply say square root and then pass whatever number that we want, let's say 16, and that will return 4. Then square root of, let's say, 111, that will be 10.535. Okay. This is just to show you that we can use lambda function with that. Of course, there's a simpler way. We can simply say math that square root and then pass our number. That's a much easier way. But this example is just to show you we can use a lambda function with a simple expression. Okay, we can also use lambda functions with list slicing. For instance, let's say we have a lambda function, takes an argument or one parameter and then returns the arguments at a specified index, let's say 0 to 4. Okay, and we can save this in a variable called, let's say, slice, and then I can call our slice lambda function and then pass our argument. It takes one argument, right? We can say Python is cool, and when we run this, it will return our argument from indexes 0 up to 4. So that means index 0, 1, 2, 3. So we'll get the first 4 characters, P, Y, T, and H. P, Y, T, and H. Similarly, we can change this to, let's say, 0 to 7. Run it again, we get Python back, Python in one space. So that's how we can use slicing. We could have also said lambda x, return x in the reverse order. Run it, we get the reverse of our slice. Okay. We could have also said return every other element. Run it again, we get pt, so every other element. That's how we can use lambda expressions or functions with list slicing. And lambda functions can also return true or false Boolean results. Okay, for instance, let's define a lambda function that will return true if a number is divisible by 4. If not, it will return false. Let's write that. So we have our lambda. Then we can say number, it takes, so number is the argument, lambda number, and then number modulus 4 is equal to 0. So it takes an argument, and then it will calculate the number modulus 4, and it will check if that's equal to 0. And if that's the case, our lambda function will return true. If not, it will return false. Let's save this in a variable called divisible div4. I'll just call it div4. Now we can call our div4 function and then pass. Let's start with a number that we know. We know that 12 is divisible by 4. So this will return true, right? Let's pass 16. We also know that's divisible by 4. Now let's pass some numbers that are not divisible by 4. Let's say 27. That will return false, right? Similarly, if we say 13, that will return false. And we can pass some random numbers. Let's say 1124. Well, that's divisible by 4. Say 7652. Let's see if that's divisible by 4. Okay. Say 763. We know that's not divisible by 4. So it returns false. So just to summarize what we have seen in this lecture, we saw that we can create lambda functions by using the lambda keyword, and lambda functions are nameless or anonymous, and we use them mainly with the map, reduce, and filter functions. And mostly we use lambda functions to create simple functions, and they don't replace the def main function definition, and we cannot have multiple statements in a lambda function. Okay, so the way we write lambda functions is lambda, and then we have our arguments or parameters, colon, and the expression. Great. Thank you everyone, and see you at the next lecture.